Okay, this is going to be example number 2. Convert xy equals 3 comma 2 into polar coordinates. And this is going to require a slightly different strategy. And the idea, again, my philosophy is, make a picture. So it's going to not for accuracy, but just to help us understand what's going on. Okay, so I'm going to make a picture, and we call that a diagram in the trade. Okay, so I'm calling it a picture because it's just me. Okay, and you got your 3, you got your 2, and of course we're supposed to know Pythagorean theorem, so r squared equals 3 squared plus 2 squared under radical. Whoops, sorry, we're just looking for r. Okay, so r would be radical 13. And as soon as we get that, we realize, hey, this is not going to be a special right triangle. We're probably going to have to go into calculators. So our idea is we have to specify an r and a theta. An r we just got. So we're sort of halfway home. Okay. All right. Now, as far as getting theta, the idea is find this angle. The tangent is opposite over adjacent, so the inverse tangent would be 2/3. Okay, so what we're going to do is we're going to put this in our calculator, and the basic plan is let's do this first in angle mode. So I'm going to put my calculator on, and mode I'm going to select angle, or degrees actually. Okay, and I do second arctan 2/3. I do not want to do arctan of 0.66 because then I'm rounding it off. Okay, so I hit the enter key and I get theta equals 33.69006753, yada yada yada. So that would be, looking at that, that's about 33 degrees, or closer to really 34. So if I wanted to, all right, what I could do is I could at this point say theta approximately 33.7 degrees, and combine with my value r, okay, I get that r comma theta is radical 13 comma 33.7 degrees. And that would be a suitable answer if I chose to do this in degrees. Now, the idea is what I could do is I could have departed right here, okay, from my calculator, and I could change that into radians, or what I could do, if you want, is I could go back in, change the mode, this time into radian measure, okay, and do the same thing. Arctan 2 divided by 3, and that gives me, okay, theta. Let's pull a squiggle here to indicate we're doing something a little bit different. Equals 0.5880026 035, etc. Okay, and that would be in radian measure. So if I wanted to write that as an answer, that would be perfectly acceptable. Okay, so let's go. I guess the easiest to go here. So I could have also said r comma theta. Well, radical 13 is still a value of r, and now 0.588 and radians, a little r up there, okay? So that would be an alternate way of giving the answer. Now, if you wanted to, of course, what you could have done, okay, is you could have stayed in, I guess it doesn't matter at this point, but I'm going to go back to degree mode. And what I could have done is when I had this answer in my calculator, I'll go back a few steps. All right, let's clear. Let's go back to our arc tan of 2/3. Okay, so I got my 33.69 and change, and what I could do is I could simply multiply that by pi over 180. Whoops, sorry, I mistyped something. Okay, pi slash 180. Okay, that's not working out. What did I do wrong here? This is in degrees. Multiply by, oh, I think I've got the wrong, yeah, okay. Go back to that, 33.6 times second pi divided by 180. I didn't go back far enough, and then I get my 0.588, okay? So in other words, I could have worked in degrees and then changed this into radians, or I could have gone back to my calculator, put it in, in radian mode and then done this. So either way, two possible answers, and the correct one, well, they're both correct, but the more correct one is the one that fulfills the requirements in the problem, okay? So that was example 2. Examples 3 and 4 are going to go the other way. We'll start in the polar, we'll convert them into rectangular XY. Okay, so let me turn this off. Bingo.